Hello YouTube! In this video we're going to be completing an application problem which we highlight the use of the law of cosines. Okay, doing this application problem because it's good, that's why you should be using the law of cosines in the first place, but also because it deals with bearings, which happens to be a point of contention for a lot of my students a lot of the time, finding bearings. And then the last reason why I'm doing this is because we're using the law of cosines, you'll see here in a minute, to determine an angle, which is not a side length. Of course, we spend a lot of time searching for side lengths, but we often spend time searching for angles as well. So let's go ahead and take a look at the situation, and we'll get into a few details. It says a ship travels 60 miles due east, then adjusts its course northward as shown to the right. After traveling 80 miles in that direction, the ship is 139 miles from its point of departure. Describe the bearing from point B to point C. Okay, so a few things about this. You'll notice here that I've already got our ship or our vessel traveling from A to B at 60 miles of distance, and we say B to C at 80 miles of distance, and we're being told that this ship is now 139 miles from its original departure course. And then the other thing we want to do is describe the bearing from point B to point C. Now recall that bearing is a north-south type of measurement. We say north, south, and what it does is it says, okay, so either start north or south. In this case, let's say we're going from B to C. You can imagine this north-south line running through this here. We say we're starting up north, okay, and we want to know how far to deviate from north towards, in this case, the point C. It'd be deviating toward the east, so it'd be something like this. We say start up north, which would be start up north here, and then deviate so many degrees in this direction. So we're really searching for this angle right here, just to keep that in mind. So in order to do this, we're actually going to search for the entire angle B first and then modify what we know about it. Okay? So let's go ahead and get started here. Recall that the law of cosines, there are three different forms of it, but the most simple form to deal with is this a squared equals b squared plus c squared. So it looks very Pythagorean. It's not, but it looks like it. Minus 2, now we're going to use b and c because those were the two side lengths we use here, 2bc times cosine of, and in this case angle A, because we started with side length A. And so now we have the alternate forms of this formula. In this case, since we want to know the bearing from point B to point C, we're going to use the b form of this formula. So we say b squared equals the sum of the squares of the other two side lengths, so a squared plus c squared, minus 2 would be ac times cosine of b. And in this case, we need to get at the b. So in order to do this, as a matter of fact, we've got a third law of cosines formula. But what I want to do is this, actually. Since we're going to need to solve for cosine of b anyways, we might as well go ahead and do that now and present an alternate form of this law of cosines formula. So of course, I would say recognize this, memorize the first one, memorize the third one that we haven't listed here. But let's say we did want to solve for cosine of b here. Well, then it would be fair to say that we could subtract these constants off of this side. So minus a squared minus c squared. So minus a squared minus c squared. And so what we end up with is this. On the left-hand side, we have b squared minus a squared minus c squared. Okay, on the right-hand side, these have canceled. And this is now equal to negative 2 ac times cosine of b. Notice I just got that from here after eliminating those two quantities. So now we would take both sides, we divide them by, oops, let's do this, negative 2ac. What this does is it goes ahead and isolates our cosine b for us. So we have cosine of b is equal to, now I'm going to use, say this negative here, I'm going to make it positive. But that alternates everybody's signs up top, and I'm going to rearrange things a little bit here. So we have this, we have a squared plus c squared minus b squared all over 2ac. Now, this is one alternate form of the very same formula we started with, except for cosine of b has already been isolated. So let's talk about this. This is cosine of b. It's a squared plus c squared. You'll notice that those two quantities up top are the ones being summed. Those are the same two that are also have 2 for a coefficient down bottom. When we say minus b squared, that's the same thing, same letters are cosine of that angle. So suppose we could do this, if we wanted to list another one, we say, well, then what would cosine of a be? Well, cosine of a would be the sum of the other two side lengths, so we say b squared plus c squared minus a squared, because we're dealing with an a here, that'll be the thing that gets subtracted over here, and this is all over 2, and then we say bc, because those were the two side lengths that were being summed. And we can do the same thing with cosine of c. but fireworks out of this one because we're going to use it. So now here's what we've got. We say, well, then it is the case that the cosine of this angle B up top is equal to a squared plus c squared minus b squared all over 2ac. So let's make sure we've got our sides straight here. We say, well, then this is side length A, this is side length C, and this is side length B. So we say, okay, well, in this case, we've got A, C, B, A, C. So we say A and C, respectively, happen to be 80 miles and 60 miles. Mi. Don't confuse it for meters. We say 80 miles, 60 miles. And then this last one here is going to be our B, is 139 miles. Okay? And so now we just need to calculate this. We say cosine of B therefore comes out to be some quantity here. Now if we've done this right, recall that cosine, it's always between and including -1 and 1. So you should get some sort of decimal here. But we say 80 squared plus 60 squared minus 139 squared. So we say 80 squared plus 60 squared minus 139 quantity squared. So on top we get looks like 9321 and negative. So let's make sure I haven't typed in anything incorrectly here. I just want to be certain. We say 80 squared. So, well, come on now. 80 squared, that'd be what? 6,400. We say 60 squared, that is 3,600. So that's an even 10 thou minus 139 squared. 139 quantity squared. Well, it certainly is that. So 9321, just making sure. So I'll go ahead and take those out of there. Not a problem. Negative 9321 on top. And on bottom we have 2 times 80 is 160, and 160 times 60. So 160 times 60 is 9600. So now we have this. 9600, which is approximately negative 0 point. So now 9321, so 9321 divided by 9600 is approximately, we'll go out 4 decimal places here, but 9709. 9709, and that's negative in this case, so 9709. So now the only thing we have remaining to do here is take the arc cosine and the cosine inverse of both sides. So cosine inverse cancels out our cosine over here. We get B is approximately, when you take the cosine inverse of this, we say cosine inverse of negative 0.9709. So cosine inverse, our cosine of negative 0.9709. We get approximately 166 degrees. So we're going to go with the nice rounded off number here, about 166 degrees. So now looking at our triangle up top here, maybe we switch our colors. If I can get my, there we go. I like a green. If I'm going to go, it's about 166 degrees here. So recall that all we needed was the bearing. So that's like north so many degrees this way. And if this is what we have here, what we'll do is we'll take this big fat right angle here. We'll cut it off our 166. So 166 minus 90 degrees here. And I do believe that yields 76 degrees. So in terms of a bearing, we could say then it is north 76 degrees towards the east. So we'd say the bearing, if we had to list this out here, bearing is north 76 degrees east. So yeah, a really good application problem. You know, talk about an alternate use of the law of cosines formula, one where we find an angle, and also we talk about bearings. So enjoy.